Hello, welcome back to another LeetCode problem. This is another easy one, but you'll be asked stuff about binary trees all the time. Again, this is another one in the top interview 150, so it's a commonly asked problem. And this asks you to invert the binary tree. So basically, just make like a mirror image of the original binary tree here. So we can use a recursive algorithm for this, and it's a pretty simple one. And so I'm just going to use this invert tree function recursively. So one thing we need to check is that the root that they give us, that we don't have an empty tree. If we do have an empty tree, we can't do anything with the root. We just need to return none. And then what we're going to do is we're going to make a temporary variable to hold the value of the left side while we swap the left and the right side. And this is just going to be the nodes. We're going to swap the entire node. So, and we're going to do this if either side has a node there. If neither side has a node, we don't need to keep going with the algorithm. We can just return the root at that point. But if the left or the right side has a node, then we need to swap it to the other side. The nodes need to be swapped. So what we're going to do, if root.left or root.right, then temp equals root.left. Root.left equals root.right, and then root.right equals temp. All right, I just want to explain what we're looking at so far. So now we have swapped the left and the right side. So what we're looking at is that this 7 is over here and this 2 is over here, but still on the left side, underneath the 7, we have a 6 on the left and a 9 on the right. What we need to do is we need to swap those. So that's why we need to do the recursive algorithm. So if at this point, if we have a left-hand side, then we need to swap all the child nodes, all the nodes underneath that one. So at this point, 7 would be over here and 6 and 9 would be underneath it. Now we need to call the function on this node and invert the tree. We'll continue to recursively call the function downward. What it'll actually do is it'll do all the ones, because we're we're telling it to do the left side first. It will do all the left sides first, kind of go down in this direction, and then it'll call itself on the right sides as it's coming back up, and then come over here to the right side, and then do the same process again. So your dot left yourself dot invert tree, and because this is a class function, you do have to put self dot invert tree root dot left if root dot right root dot right is equal to self dot invert tree root dot right, and then what we're going to do is we're going to return root. So when it gets to the point where there is no left and there is no right, which will say happen when we get down to 1, for example, it'll just return the root, which will be 1 for because it's that is the last thing we called the function on. And that will go into the and it'll be because the 1 will have been swapped already at that point because we're swapping it on the way down. That will go into the root dot right here. We'll say root dot right equals self dot invert tree. That's when it comes back on the callback. And so we can give this a shot. And there you go. All right, thank you for watching. I'll see you next time.